Okay, now that you know the history of protons, neutrons, and electrons and how they are positioned in our atoms, how can we count the number of protons, neutrons, and electrons in our atoms? And that brings us to the second section of the book, where we start to talk about the atomic number, also given the symbol Z. Okay, this is the number of protons in the nucleus of the atom for that element. Okay, so it depends on how your periodic table is structured, but if you take that out, you will see that in one of the corners will be a key. Okay, so make sure that you consult the key or the legend of the periodic table, because on the periodic table it'll tell you the atomic number. So you'll see hydrogen is 1, and that means that it has 1 proton. Okay, helium is 2, it has 2 protons. Lithium is 3, beryllium is 4, boron is 5, carbon is 6, etc., as you go on, and that is the order that they are in the periodic table. It is not alphabetical, it is not chronological, it is done by their number of protons, and it's really cool. Now, the other interesting part is that since all of our atoms are electrically neutral, that means that this is also the number of electrons. So the atomic number is the number of protons and electrons of neutral atoms. And we'll talk about when they're not neutral in a little bit. Okay? So, if we take a look at our number of protons and electrons, how can we figure out the number of neutrons? That's through something called the mass number. And the mass number tells you the protons and neutrons in the nucleus. There's no place on the periodic table where it tells you the number of neutrons. You have to do a simple calculation to figure it out. Okay, so in order to figure out your number of neutrons, you take the mass number and you subtract the atomic number. Now, since the mass number is your number of protons and neutrons, and your atomic number is the number of protons, you're basically canceling out your protons, and it gives you your neutrons. So here's the big question. Where do I find the mass number? There's 2 places where you find it. It's either going to be in a hyphen notation or a nuclear notation on your paper. Okay, it is not on the periodic table. Okay, really important to know. It's not on the periodic table. Okay, the mass number is not equal to the atomic mass that is on the periodic table. And we're going to talk about that even more in upcoming videos. Okay, so the hyphen notation would be if the element name is spelled out, there's a hyphen and there's a 9 after it. The 9 is the mass number for beryllium. Well, if it's written out as a symbol, okay, the nuclear notation would be the top left-hand number up here, okay? So you would look on your periodic table, you would find that beryllium is number 4, meaning it has 4 protons, and that is written in this bottom left-hand corner around a nucleus. It might not be the same on the key for your periodic table, so be very careful with that, okay? So what does that mean for my numbers of protons, neutrons, and electrons of this specific atom right here? Well, beryllium would be number 4. Okay, since it's neutral, it has 4 electrons. How many neutrons does it have? Well, it's mass number minus atomic number. So this top number minus this bottom number. 9 minus 4 gives me 5 neutrons. It won't always be the same as your number of protons and electrons, and it actually is quite different. So now, what we're going to do is we're going to introduce one of the most important concepts of the whole course, ions. All right, so be ready for it because we're going to refer back to these all the time. Ions are non-neutral atoms. They have different numbers of electrons. So if you think back to the model of the atom, we're not going to mess with the nucleus. We're going to mess with the electrons in the electron cloud around it. So we can take these really tiny little atoms, or these really tiny electrons, and remove them or add them. So if we have a cation or cation, okay, they have less electrons than protons. Cations are positively charged. Cats are positively charged. Meow. Get it? All right, so cats also has a T in it, and a T looks like a positive sign, and that's how you can remember cations are positively charged. Well, how are you positively charged? When you have more protons than electrons. So that means that you have to have less electrons in your atom. Anions are the negatively charged atoms. They have more electrons than protons. So they have gained some of their electrons. Okay, anions kind of look like the word onions, and onions are going to be like, bleh, make you cry. All right. Oxygen is going to be number 8 on the periodic table. So you'll see it has 2 plus 6, meaning 8 of these electrons. But the oxide ion is O2 minus. So that means it has 2 more electrons than these right here. So 8 plus 2 gives me 10 total electrons. Calcium makes a 2 plus ion. Calcium is number 20 on the periodic table. So if it has 20 protons but is a 2 plus, that means it has 18 electrons. Okay, so that's how we end up getting all of those to form. So what we'll see here is this really nice summary chart. Okay, so when we are working with our atoms, you'll see that we have mass number in this upper left-hand corner. We'll have the charge in the upper right-hand corner and the atomic number around our symbol. This is the symbol for our element. Okay, there's nothing specifically in this bottom right-hand corner because that's typically where we put our subscripts when we have our atoms. Okay, so let's figure out how many protons, neutrons, and electrons each one of these atoms have. Okay, so please take out a periodic table. If you need to pause and come back for it, that's great, no problem. And I want you to find oxygen on the periodic table. Okay, so oxygen's on the right-hand side. Oxygen is going to have an atomic number of 8. So I'm going to add that in. Atomic numbers won't always be written here. Sometimes you got to look them up. Okay, so protons, we have 8. Okay, neutrons, I have my mass number minus my atomic number. So that is 15 minus 8, giving me 7. And this is a 2 minus charge. So I'm going to have more electrons than protons. I'm going to have 2 more. So that means I have 10 electrons there. Okay, find strontium on the periodic table. He's all the way on the left-hand side. So he's number 38. So that means I have 38 protons. Okay, then if you take your number of protons and your mass number, you do 89 minus 38, and we get 51. Wow, it's a lot of neutrons. How many electrons are we supposed to have? Okay, if we have a 2 plus, that means we're going to have 2 more of our protons than we are of our electrons. So we're going to have 36. And then lastly, if we have silver here, okay, silver is in the middle of our periodic table. Silver is number 47. So that means we have 47 protons. If we subtract out our mass number from, or our atomic number from our mass number, we're going to see that we have 60 neutrons. And if it is a plus, that means 1 plus. That means I'm going to have 1 more proton. Sorry, 1 less electron than our protons, and give me 46. All right, down here at the bottom is the PhET simulator, which has us build an atom. So I am going to switch over to that. And you'll see in this build an atom, it is awesome. Um, you can go to this nice little build an atom where you can bring in your number of protons and it shows you the symbol, the atomic number, and the charge. You can add a neutron. You can add an electron. I can try to add the electrons to the middle, but they don't. They come out. You can see when I add my protons here, they get increasingly unstable because there's a lot of positive charge inside, and my tally's up here. And I can take and kind of make it all chill out by adding the appropriate number of um, neutrons inside, and then I can add electrons so that I can start to change the actual charge, and I can make different kinds of charge cations and anions. So you can remove, add, drag, drop, and one of the things that I really like it for is it has this game mode inside, and you can quiz yourself with how that all works. All right, so that is protons, neutrons, and electrons.